Hey folks, today we have Samir with us. Samir is SWE at Front Row and is doing an awesome job helping us to know about GraphQL. So yeah, over to you, Samir.
Thanks, Abir, and thanks, Tech Phantoms. This is an awesome opportunity. Although it's been a while
Yeah,
that I worked with GraphQL, I had to revise a few things
yeah,
because I was using it a lot last year. But yeah, it's great. I hope I get to share a lot of things and all the viewers
hmm,
learn a few new things. So yeah,
yeah.
excited to get started.
So yeah, let's get started with GraphQL 101. Yeah,
Yeah, share my screen.
yeah. Please go ahead. Yeah, I guess.
Okay, think everybody can see it.
Yeah,
So
it's
welcome
visible.
again to GraphQL APIs 101. So I hope to introduce you to GraphQL and show a little bit about how GraphQL can be used to burden to lessen the burden of what you do with REST. So yeah, a bit about me. So currently I'm working as a software engineer at Frontend. I mainly work with Flutter in the mobile app and a bit of Node.js in the backend. And previously, I was also part of a few fellowships and programs which helped me really grow and explore a lot of technologies, meet awesome people like Abir. And yeah, I'm grateful for that. And I also got an awesome opportunity last year, which was the last event I attended live before lockdown happened, which was GraphQL Asia, the biggest GraphQL event around the world. So it was happening in Bangalore, and luckily I got a scholarship ticket because of since I was discovering GraphQL from Hasura. So it was an amazing time. I saw a lot of companies use GraphQL at scale, like PayPal, LinkedIn, and all of these big companies were present, and it was amazing. So was the food actually. So yeah, let's get started. So why do we need GraphQL, or why was GraphQL invented? So I think we have to first see what are the problems with REST APIs. REST APIs are actually pretty good. Like we use them, we've been using them for years, and we all love it. I think most of us love it. But there are certain problems and certain pain points, especially for both a front end and a back end developer. It requires multiple trip times sometimes if you have to fetch multiple data entries. Sometimes it can also over and under fetch. Suppose if you are on a post screen and you require only the user avatar and the user name, but you're getting the entire user object. But then when you click on the user and you click on the user profile, you need the entire user object. But then you should have to make another API call for that. So instead, to a different route. So instead, in GraphQL, you can get only the data you require at any point. So you don't have to get the entire data which you don't need at that point. So that was the whole intention of GraphQL, like fetch only the data you require and not anything more. And then REST APIs have too many endpoints to remember, and each of them have to be documented, right? So each REST API has different endpoints, but GraphQL has only one endpoint. There's just a post request to slash GraphQL, and that is a single endpoint which you query all the data from. So you don't have to remember too many endpoints, and you make sure that you get the data that you require. And REST is schemaless. So this can sometimes cause trouble when we are trying to establish relationships. Because it is schemaless, it doesn't provide us any error validation or anything of that sort to make sure that we are using the right objects and we are sending the right relationships with the data we want. So yeah, a brief history of GraphQL. So GraphQL is actually a specification rather than a language or a framework. It is more. It was developed by Facebook, and it's an alternative to RESTful API, like I mentioned. This was just done by three engineers who were one day trying to optimize all the REST APIs that were taking up a lot of API requests, and that is how they came up with GraphQL. So let's dive in a bit more deeper into GraphQL and how it works and what it provides. So like I told, REST APIs do not have a type system, or they don't have a strong enough type and relationship system. But GraphQL is completely opposite. It requires you to have a relationship at all times. So it is best used with relational data. So these are the types supported by GraphQL. The first thing is ID. So in a JSON or in REST, we don't have something called an ID. We just pass it as an int or a string. But in GraphQL, you can have a specific ID parameter which identifies any certain object. And then you also have int, float, boolean, and also you can have custom scalars like date and time and whatever. You can also sort of use it like a programming language where you can create interfaces, unions, and different cool things where using the programming knowledge you already have. And this will structure your APIs better and will give you more clarity on what you're sending and what you're consuming. So let's take a look at what are the basics in GraphQL. So basically there are four things. One is the type system, which I already mentioned. So GraphQL is very strict about type. So you cannot consume or send type that isn't there in GraphQL. So if a field has a string type, then it has to be a string type. Or if it is an ID, it has to be an ID. An ID here can be an int or string, but technically they like string and ID don't mix. And then the next thing is queries. So in REST, we have GET requests or we have different requests of the HTTP methods. But in GraphQL, since we have only post requests to make to the GraphQL endpoint, this is how we differentiate uh, our requests. Basically, there are three types. One is called a query. So query is when you're trying to fetch some data. And this is how you tell GraphQL that I want this data, give me this data. And that's how GraphQL gives it to you. And then mutation is the opposite of it, is when we are trying to save data in the server, and that's when we do mutation, which basically means that you're mutating data, right? And this is how you send it. You just send it as a you send it. It's like it's like a function call. You just send it like a function call, and it returns some data. And then we have subscriptions. So in Rust, there is no way to implement listening to different sockets or listening to different clients. But in GraphQL, you can easily do this using a concept called subscriptions. So you won't have to implement something like WebSocket additionally to whatever API you're already building. So let's dive a bit deeper into GraphQL queries. So how does a query look? In Rest, you would usually have something like this. You have users, and you want a particular user. You have to do slash. You have to call another endpoint slash users ID slash post, and then if you want the particular post, you have to call slash user ID slash post. So it goes on. The more data nested deeply you want, the more deeper your endpoint will be. But in GraphQL, you can just specify the data like this, and if it's nested, you can just specify it right there. So you see, I have users, ID, email, name, and then posts, which are all the posts that belong to a particular user. So I don't have to make multiple requests to fetch all of them. I can just fetch it in one request. And then mutations. So like I mentioned, in REST again, you would have to make multiple. You have to like take different endpoints to make different kind of post requests. But in this, you can just type mutation with the keyword mutation, and you choose whichever function you want. Here I'm choosing to I'm writing create post, which is a function defined in the schema of GraphQL, so it knows what operation I'm asking for, and it will do that operation. And then we have subscriptions. So subscriptions, like I said, is a way to listen to different endpoints. And in GraphQL, you can create different subscriptions and make two clients listen to them without implementing something like WebSockets. So that is an advantage. So let's get a bit into the demo here of what all concepts I just told. So I have an entire GraphQL, a basic GraphQL server ready here, and I want to just explore how we can do this in an actual server. So there are multiple varieties of ways you can do this, and the most popular one is called Apollo. So Apollo is a sort of a framework for integrating GraphQL APIs both on the server and the client, and it gives us easy methods and ways to create a GraphQL server and integrate it with any existing services you have. So right now, I just have a basic HTTP server. If you have created a Node.js app, this is very familiar syntax. You just create an app with Express, then you create a server. So then we have resolvers. So resolvers is what uh, uh, takes in what transforms your data. So when I call the mutation create post, Resolver, it's the responsibility of the resolver to make sure that it's creating a post or whatever that create post is supposed to mean. In my view, the create post is supposed to add a new post object into the data, right? And that is the work of resolver to make sure that that data is added, because GraphQL only gives a specification or a schema to tell that this is what it is, but the actual computation that has to be done is taken care by resolvers. And then we have schema. So schema is where you define all the data you require and the shape of all the data, how it will look, including your queries and mutations. So this is what gives the GraphQL Explorer the ability to explore the schema. And then here I've just put some JavaScript objects to not use complicated using a database. So I have like two posts and one user here. So actually, let's start with by defining a schema so that we get a good idea of how it will look, right? So I think the first thing I need is post. So this is the basic schema of a post. It will have an ID, title, content, and an author. So you can see that I'm referencing author as user here, which I haven't created yet, but this is how you can connect relationships in GraphQL types. So you can have a post and and you can mention the type user to be this field. So when I'm in the endpoint, when I query for posts, it will make sure that it returns the user object as the entire user object as well with me. And then I have user, and for user again, I have a list. A user can have a list of posts. So I just put post inside the brackets. And then we have queries. So queries, like I mentioned, are the get, sort of like the get request is the data you are fetching. So the possible queries I can think of here are posts, users, and search user. You could have multiple like search posts and so on. It depends on your use case. But for the sake of simplicity, I'm just defining three queries here. So post will return a list of posts, and if it's empty, it won't return anything. And the users will return a list of users. So for a query or a mutation, for everything, we have to mention a return type. And you can see that this search user will be a function, but it will return a user. So this is how we specify that something will be of this return type. And then we have mutations. So I created two mutations here. One is create post and the other is create user. And create post basically returns a post, and create user returns a user, the user that was created. And then let's also create a subscription. So this subscription is going to listen to when a post is created and then inform the other client that this post was created. So this could be useful in multiple scenarios, especially for chat applications. Using GraphQL would be a time saver because of the complexity involved. If you observe one thing, that I have a lot of exclamations at each point. So this means that this data has to go through, like ID cannot be null. So GraphQL also gives us null safety in a way that some data you specify should not be null, else GraphQL, the server will throw an error. So that this is how you can make sure that some of the data you want are not null and are always present. And it does make sense, like because in some cases an ID can never be null. And so can just create the post that was created cannot be null. So that post must be returned. It goes on. And then let's go to the resolvers now. So like I said, in resolvers is where we implement all the logic of whatever request we're coming, how do we transform it and actually give back the data. So whatever you define, whatever definitions and types you mentioned in the schema, that is the same thing you'll be using or giving it an implementation. So for a query, you can mention so this is how you basically mention resolvers. You mention it as an object, and then you give it different you keep on giving it different keys, and then for each query you give it what function it has to do. So I'm importing the data I showed from that file, and for users I just return all the users, and for posts I just return all the posts, and for search user I'm just using a find JavaScript find function to just return that user. I'm also returning an error if that user does not exist. And similarly, we can create two more things. So this is a bit tricky. So what the common mistake in GraphQL is, although we have mentioned that a user object is supposed to go for an author, I am only storing uh, I'm only storing the author ID. in the post object. So I don't have the entire user object stored within the post object. So for that, what we do is in whenever the so we can specify different parameters like this for whenever that object needs to be sent with another set of object. So here currently I have for post I had users. So for post for post object I have an author field where I'm supposed to return an user object. So that is how I return. So I just find that user object and this parameter will be available in parent. So in author, I basically had the author ID stored. So using the author ID, that data I can compare and I can just send that particular user whose post this belongs to. And similarly for posts I had a use like for users I had a post argument, and the same thing goes here for posts. I can just filter out the posts that were of that particular author and just send it back. So this is required when we are nesting data types and we are nesting different data objects, and this is how we implement it. And without this, it will just send a null and it won't work. So next is the mutation. So like I showed, there were two mutations. One is create post, another is create user. So I just take the whatever arguments I'm passing and just push it into the post object, and then just return that particular object. And same for create user. I just create the user and then just return that user. And then the last thing we had was subscription. So for subscription, there is some complex implementation, and this could be done in multiple ways. But one popular way right now, the easiest way, is something called PubSub from a library called GraphQL subscriptions. So you just declare a PubSub client, and whenever the user subscribes, just give it a key. Just like if you're familiar with a publisher subscriber pattern, this is how it usually be. So on subscribe we just send it to this particular key, and if you see, observe here in the create post method, I am sending to that particular same publisher the data that it requires. So every time I create a new post, this whatever client is listening to this particular subscription will receive that data, and that's how it works. So let's implement the main part now, which is the server itself. So right now I have type dev sum resolvers. So this is required for any GraphQL server to create the entire thing, because this is how it knows what is the schema of it and what are the different functions that will help arrive at the solution or implement the logic. So I import type devs and resolvers from schema and resolvers, which I created and just showed. And these are some functions that are available from GraphQL tools and different libraries that help you in creating different kinds of data shapes or objects that are required for certain servers. In this case, we need an executable schema, and that's what we took here. And then we have an Apollo server. So this is exported from Apollo Server Express. This server is particularly required because we are using the subscription feature. Else it would be much simpler. So here we're defining a subscription server basically, and we have some plugins, and we have called when to use the subscription server and when to close it, and all that logic basically. And then we create a new subscription server, which we're using it to close and listen to when the server stops. And then we'll just have the final server, which is this, which was the Apollo server. And then we just start it, apply the middleware to that server, and then use the basic HTTP server to start the server. So I think that should be it. We should be ready with our app to make different queries, mutations, and subscriptions. So let's check out if it works or not. So our server is running at localhost 4000/GraphQL. So there are multiple utilities where you can explore this. So unlike REST, so in REST you have to use an external tool to document everything like Swagger or Open Docs or something. But in case of GraphQL, everything is self-documented because of the type system, and because you're defining everything and telling the server that this is what the shape of the data is. The GraphQL client or the explorer can call that schema and list out everything that belongs to a particular server. So you can see here Let me just refresh. So yeah, this is one particular uh, Explorer. There are multiple. So this is from Apollo, because I'm using the Apollo server, but there's GraphQL Yoga and multiple others that you can use to do the exact same thing that I'm doing. So in queries, we have, like I showed, we had post users and search user. So currently I'm using the query users and that's why it's ticked. And if I'm a front-end developer and I want to know what this users returns, I can easily see here of everything that it returns. So it even shows which data I'm asking for and which I'm not asking for. And this basically makes the life of a front-end engineer so simple, as well as the backend, because he doesn't have to specifically document or anything within the server. Everything, all the shape of the data and everything is self-documented in GraphQL, and you easily get to know it. So right now I have users, and as I remember, I had one user. So let me try to query it, and posts were two, I guess. So if you see that everything is returned, everything that I asked for is returned. So there's ID, there is there's ID, there's name, there's email, and the posts. So every post that I made is also there. There were two posts, so it is there. And if I wanted something lesser, if I didn't want my email, if I just wanted my name and the post, or even in the post, if I didn't want the title, I just wanted the content, I can just ask for that much, and GraphQL will give me only that much. So that is the beauty of GraphQL, that you don't need to fetch any more than you require. And this helps and eases development a lot. So we have other uh, queries as well. Let's try out those. And you can also see that it assists in the type system, assists in makes to making sure that you are asking for the right fields and the right data. It also has autocomplete, which you wouldn't typically get in REST. So it is showing what all I can take, what all data can be asked. So here I have posts, and for each post I'm asking for the author. So post one, it has the title, content, and author. The entire author object is returned. And same for post two. So let's head to mutations and see if we can change it a bit more. So for query, so every operation has a keyword, and this was query. So let's make it mutation now. So we have create post and create user. Let's create a post. So you can see like Apollo does some kind of variables. So there are different concepts. Like GraphQL is a huge thing, and like you can see, you can just create variables. You can create fragments and join them. Like I showed, you can create multiple things to make your code as modular as possible. In this case, it just created some uh, variables that I can put, and so that my code is organized. So I'll just go ahead and do that. And the return data I'll ask for is ID, title, and content. And you can optionally also get a type name. If you don't know which type you're getting, you can also ask for that and it will return it. So let's create a post. So it will be has, and the author ID is 1, which is the only author present right now in our database. And the create content will be uh, GraphQL 101. Okay, let's run this mutation and see what happens. So it did successfully create it, and that's why we're getting back the data. And if we query the same data right now, so what are the posts? There should be a third post, and it is there. So you can see that we have the same author and everything. So we also have, so you can also basically implement search in GraphQL, and that will also be a query. So let me just try to search a user that is there and not there. So search user ID is 1. So 1 is there, right? And yeah, 1 is there, so it is written in the data. But what happens if I do 2? So I did enter this message. So GraphQL also gives us some nice way of displaying errors. You can see that it displays everything about the error with the message I sent. So it doesn't just crash the server or whatever happens in the normal server application. It does give you what happened, but it also gives the message, and that is also displayed in a proper JSON format. So that is the amazing thing about GraphQL. Then one, it's there. So let's try to create a new user before we move to subscriptions. So there was create user, and for create user, I need the name. I'll put Abir, and then email. I'll just put com. Then bio, we do. So we should have one more user. So yeah, and one more thing about GraphQL is that you always have to fetch at least one data field. You cannot have an empty response. So you always have to request at least one data field. Let's see. And we did create a new user. So if we go back to our queries and try to fetch, or let's try to fetch number 2, and we should see Abir. Yeah. So there you have it. So we just created a new user as well. So let's go back and try our subscriptions now. How does the subscription work? So there was subscription, and there's only one subscription right now, post created. And then I have the ID of the post, the title of the post, and the content of the post. Right. So the way the subscription works, it continuously listens to the server, and every time the server posts some kind of update, it just prints it here. So if I start listening, you can see that there's a listening circular indicator. That means the server is listening to whatever is happening, and we can go ahead and create post. Let me just move that. Create post, and then we need the ID, title, content. And the post content will be. So now this post I create should appear in the subscriptions. So it was created successfully. Let's see if it's come in the subscriptions, and it has. So this way you can implement this for multiple use cases where you're listening to a feed, listening to notifications, or listening to chat messages, and it's that easy. You just have to mention that, define the type of it, define it in the resolver, and whatever is there, just push it to the subscription, and it will push it to the client. So it was that easy. So that's it, I guess, for most of the demonstration part. Let's get back and see some of the real world use cases and when you should use a GraphQL API and what are the options and what are furthermore resources. So GraphQL should mostly be used to unify an API to make everything central and to give a proper API interface for the front end. So this is how it's typically done. You might have multiple microservices. You might have uh, different services such as Twilio, SendGrid for emailing, text messaging, and then payments gateway. So all of this usually do give out a JSON response. So your GraphQL server should combine all of these responses, all of these different services, and make it into a unified GraphQL API. This is how it will help the front end communicate effectively and efficiently without having to deal with a lot of JSON response, different endpoints for each and every request. And what are the further resources you might want? So Apollo is the most popular one to learn GraphQL and to implement as well. You can play around with it. And they have multiple examples and multiple use cases described in their documentation. The GraphQL organization by Facebook, which is currently an independent organization, also has a lot of resources to get started with GraphQL and learn everything about it. And then we also have an awesome GraphQL repository which has different implementations in different language. So because GraphQL is not a language dependent, it is not defined by any programming language. It can be implemented in every language, and every framework or language does support GraphQL, and there is always some library for it. So whatever developer you are, either front end or back end, or any language you do, you should be able to implement GraphQL successfully in your application. And then this was how you can create your own GraphQL server. But what if you do not want to create one and you just want the cloud to take care of it? Well, there are services for that as well. So Hasura is the most famous and the easiest one to do. You just have to connect your database and put in whatever tables you have or whatever relationships you have, and Hasura will create all the different mutations and queries for you. Because everything is a CRUD operation, it can easily predict, like for each instance or each relationship, there can only be like 4 or 5 possible actions. Like for user, you could create user, get the user, and then delete the user or update the user. So Hasura will create all of these mutations and queries auto-generated for you, so you don't have to define your own resolvers. And then we also have AWS services, which is AppSync, and also Amplify also supports GraphQL. So you can leave it to the cloud and just query the data and send the data, and all these cloud services will manage all of your headache of writing a server and scale as well. So yeah, thank you for your time, and I hope this helped. I hope to see what great apps you build, and if you want to connect with me or want to uh, get these slides, do connect with me on Twitter or LinkedIn. I'm always active, and I will reply to you. And also check out some of my projects on GitHub. Uh, I have a ton of them. So thanks a lot. Thanks, Abir.
Yeah, sorry.
Yeah.
Yeah. So this really awesome session. I was like really exploring GraphQL once, like a day before, like what it actually does, and then got to know like it's something like you're running a query and just getting the data what you need. So yeah, it's a great thing that everyone should like know this, explore this stuff. And I guess there's one question from Ankit. Like I'll
Okay.
just put it. Yeah. So um, would
Uh,
you like to?
in the sense like some kind of server error or something. It's always in a JSON. Like it doesn't just throw a random error. It's always in well structured JSON. That's how it gives out
Then
errors.
I think Ankit's query is resolved in this, and also there's one question from my like perspective regarding GraphQL, that is it scalable, or like what are the use cases where we should use GraphQL or like specific.
Yeah, I think it's definitely scalable because if you've seen around Twitter, like a lot of companies have successfully implemented it. The biggest ones are PayPal and Coursera. So they're like using GraphQL at full scale. All of their services are running with GraphQL right now. They have multiple blogs on it. So do check them out. You'll get a better understanding of how GraphQL works at scale. And the use
Hmm.
cases, like I mentioned, is the most basic use case is to unify multiple different APIs and to give the front end a proper structured relational response which has a type system and where you can predict what data you're going to get. With REST API, it's not like that. You can get any data. You can join and
Hmm.
send any data. But with GraphQL,
Hmm.
you have to know the type system first, and that is the only data you can send and receive. So this helps avoid asking for data that isn't there. So in a REST API, we might send JSON keys that aren't there in the server, that doesn't come back from the server. So it usually
Yeah.
gives the server throws an error, or the server might crash, or we might get null or something. But in GraphQL, it doesn't let you do that in the first place because it already knows the schema so well. So that is the biggest
Hmm.
advantage, I guess.
Yeah, that's really like what is the specific thing that you want to do. GraphQL will help you. No need of like extra data. Yeah, that's great.
Yeah,
That's awesome. Thank you, Samir, for like sharing all this knowledge with us, and I hope that our hackers have got the real enlightenment on GraphQL and the difference between GraphQL and REST, and when to use and when not to use. And also, they will surely connect to you on Twitter, and I like they'll always like will be recording this, and like it's already recorded, and it will be shared on our YouTube channel with our hackers. So they'll be probably reaching you out after the session.
yeah, great. Like
Yeah,
I'll love to see what they build on GraphQL at Happy Acts, I guess.
yeah, yeah. And so that's all, folks, for today. Thank you, Samir, for for being here, spending time with us.
Yeah, thanks for the opportunity. It was amazing
Yeah, yeah.
talking to you. Okay then, see you.
Okay.